Hello friends, what's the smallest charge a particle can have and which particle can have that charge? I repeat my question, what's the smallest possible charge in this universe and which particle carry that charge? So let me answer you to be very simple and loosely speaking. Charge on an electron or the charge on a proton is the smallest possible charge in this universe. So what's the charge on an electron? The charge on an electron is given by 1.6 into 10 to the power minus 19 coulomb. Fine folks. So this is the smallest charge possible in this universe. And the particle that carries this charge is an electron or a proton. So this is the charge on an electron or a charge on a proton. And this is the smallest possible charge possible in this universe. And the carrier of this charge is an electron or a proton. The charge on an electron is 1.6 into 10 to the power minus 19 coulomb. And the charge on a proton is also given by 1.6 into 10 to the power minus 19 coulomb. Every electron in this universe carries the same amount of charge, and that amount is 1.6 into 10 to the power minus 19 coulomb. Every proton in this universe carries this much amount of charge, and it's given a symbol, and the symbol is E. So we have here E equals to 1.6 into 10 to the power minus 19 coulomb. And this is nothing but the elementary charge. This is called elementary charge. This is elementary charge or the basic unit of charge. E is the elementary charge or the basic unit of charge. It's so because it can't be split up. None can have the charge smaller than 1.6 into 10 to the power minus 19 coulomb. It can't be split up. Electron cannot be split up. Proton can't be split up. So this one is the elementary charge or the basic unit of charge. Fine. Let me add some more information on this one. Most recent discoveries have shown that neutrons and protons are made of quarks, but we don't consider these quarks as elementary charge or the basic unit of charge because these quarks do not exist in free state. So the only elementary charge that can exist in free state is this one. Is that clear? Is this one. So this is nothing but a charge on a proton or a charge on an electron. So right now I am speaking about the value. This is the value. This one is the value of the charge on a proton or a charge on an electron. By convention, the charge on an electron is taken to be negative and the charge on a proton is taken to be positive. So the charge on an electron is written as minus E. This is minus E. This one is minus E. This is a charge on an electron, and the charge on a proton is written as plus E. By convention, charge on an electron is taken to be negative, and the charge on a proton is taken to be positive. Is that clear? So, despite the facts that there are quarks, still we have this one as our elementary charge. We do not consider quarks as elementary charge because these quarks don't exist in free state. So let me give one more information. If you recall a beta positive decay or beta negative decay. So what was happening there in the beta positive decay or beta negative decay? So let's recall beta positive decay. In beta positive decay, there was a proton, and that proton changes itself into a neutron and simultaneously emits positron and the particle called neutrino. But never think that proton is made up of neutrons, a positron, and a particle called neutrino. Never think that. So in beta negative decay, what's that? In beta negative decay, a neutron changes itself into a proton and simultaneously emits electron and a particle called anti-neutrino. But once again, I will restrict you here that never think that a neutron is made up of electron and a particle called anti-neutrino. So we will not go into these details. Despite these facts, I must say you that this one is the elementary charge. Elementary charge is a charge on a proton or a charge on an electron. So friends, I hope the things have been clarified. Do subscribe and share this video. Thank you very much.